Hi, Susan.
Hello.
How are you?
Good. How are you?
Good. Hey, give me just 1 second. I think you're going to be the only one in the demo today. I've got somebody else that registered from overseas.
Okay.
They registered last week and didn't make it. So uh, give me just 1 second to grab my coffee and refill it and a cup of water, and I'll be ready to start.
Okay.
Thank you. Well, Susan, before we get started today, you may have answered some of these questions when you registered for the demo. So sorry for asking twice if that's the case, but tell me a little bit about what your experience is already with CMM Manager and what has prompted you to join today's demo, if you could.
25 years ago, I used to run a CMM and then was out of the industry and just rejoined the industry. So I'm trying to get it all back and relearn it.
Okay. So do you have some equipment now that is running CMM Manager or that could potentially run CMM Manager?
Yes, we have one, and I am slowly training and thought it would be a good idea to watch this demo.
Sure. So the system that I'm operating today is a traditional three-axis motorized system with just a traditional tactile TP20 probing. The system that you have currently, is it a motorized or manual system?
Motorized.
Okay, great. All right, so before we start, just to confirm, you should see my screen right now with CMM Manager. Is that correct?
Correct.
Great. So I've just imported a CAD model, and you should see that kind of moving around on my screen as well.
Yes.
Great. All right. So uh, using CAD is optional on a motorized system. It's probably your preferred method of operating the software for a couple of reasons. One, it will speed up your reporting process because the CAD nominal data from the part itself will be transferred automatically to the report, nominal values. But also, when we get to the point of creating feature measurements, instead of, I'm not sure how you operated years ago, but probably did a lot of joystick teaching or teaching by keyed in entries. So here you'll pick the feature from the 3D CAD model, and the software will create the measurement path for you automatically.
Right.
So that
Yeah.
will save a lot of
Yeah.
time in programming and measuring. Even if you're doing just walk-up measurement, and you don't intend to create a program. Many times it's still going to be faster to interact with the CAD model than it would be to operate the machine by joystick.
Right.
So in any case, I've brought a CAD model in, and you can see the origin of this CAD model is located, in this case, conveniently on the corner of the part. As you may know, if you've worked with CAD, it's not always the case that somebody has created a CAD model where the origin is somewhere local to the part, but it may be off in space somewhere. So we do have tools that allow you to simply pick features on the right button here. Click features on the CAD model to reestablish the CAD origin. So, the z-axis is going the wrong way, or maybe the origin's at the bottom of the part instead of the top of the part. You've got all kinds of tools to reestablish that coordinate system to your liking. So what would have happened, without these types of tools built into the metrology software is you would have to go to your CAD designer and ask them to give you another copy of that CAD data that has the origin and your specified location. So by having those tools here, it just empowers you to manipulate the CAD to your liking before you start with the measurements. So once you've imported a CAD model, we'll go to the very left side of this menu bar at the top, and it's going to be laid out in a layout that kind of mimics the typical workflow of a CMM program or CMM inspection. So alignment, features, and then report. You can ignore this vision tab. I had the machine set up recently with a camera and haven't removed the option from the software, but traditionally you're going to have those three tabs right in that order: alignment, features, and report. So we'll start in the alignment tab. You've got your usual suspects with traditional or basic alignment tools: level, align, set origin, translate, rotate, so on. You also have a set of so-called advanced alignments. Some of these will be suited for kind of normal shapes like we've got here, but maybe a case where the origin is off in space intentionally, like a in-car coordinate system. Other advanced alignments will be more suited for like a more organic or irregular shaped part. So thinking in terms of like a computer mouse, for instance, you've got typically one flat surface on the bottom of that, and then the rest of the workpiece is completely organic or irregular shape. So we've got several different types of best fit or point to CAD surface type alignments that are suitable for those types of shapes. If you're dealing with basic shapes, typically rectangular or round, something that's machined or cut on a lathe, you'll have what we call canned alignments that will give you a series of features that you can measure manually to establish your initial alignment. So plane circle circle, for instance, or cylinder point line. So all of these, the software will just walk you through those three measurements and establish the coordinate system accordingly. Most common of those is this 321, so plane line point. So in this case, I've asked the software to perform this plane line point alignment, and then in the status bar, the software will typically give you some instructions. And then this counter box that you see here is going to represent the number of points that we've measured as we go through this routine. So let me grab the joystick on the machine here, and I'm going to start by measuring 3 points on the top surface of this part. And you'll see that counter reset now from 3 now to 2, so it's asking me this time to measure a line. So I'll measure a line on the front edge of the piece. And then I'll finally measure a single point on the left-hand side of the part. Now if I zoom out a bit, you can see where my CAD model was located originally, where the machine home is for the CMM. So this is just an arbitrary coordinate system at the corner of the CMM volume. And then finally, this new coordinate system, so the one that's flashing in yellow, that represents this new measured alignment that we're creating currently. We've got a confirmation window here that gives you an opportunity to change the orientation of the alignment that you're creating. And of course, the idea here is that we're creating a coordinate system that matches the one that we have on our CAD model. So when we click OK, not only does that confirm this alignment operation, but it also automatically synchronizes the CAD model to our coordinate system. So from this point on, we could come back to the alignment tab. We've got some subsequent alignments that we want to establish, but from this point on, we can move to the features tab and start to measure some features. So again, if you're not using CAD, this blue portion of the toolbar will be suitable for just creating measurements using either the joystick or by defining the coordinates of some measured feature, by keying in coordinates, sizes, and so on. But considering we have CAD available, we can focus on these kind of gold colored buttons here in this CAD Teach group. So that plane that we measured on the top surface of the part, for instance, by joystick, we create an automatic measurement by first choosing this 3D button and then picking the 3D surface that we'd like to measure. So the software recognizes that click that I made on the CAD model as a plane feature, sets up the measurement accordingly. Using that same 3D button, if I pick on some other geometry, like this cone, for instance, the software recognizes, okay, that's not a plane this time, but instead a cone, sets up the measurement for me accordingly. So as you're adding these measured features, you get a couple options. If you're simply wanting to program and maybe you don't have the workpiece available, or you simply want to create a program in its entirety and then run it in sequence, for each of these measurements, you could simply click the OK button as I did. But you'll also notice before hitting OK, I've got a couple operations that we can perform here. First, a simulation. So visually in the CAD view, you can get a sense of how the probe is going to move and measure that feature. Also, there's a button, Verify. When I click on this, I get a warning the machine's about to move. So now the machine is moving and measuring this feature. Hold on one second. Got my probe disabled. Real quick, just run this alignment here. I've got something going on with probing on my system, I think. So at this point, I just ran my program real quick just to make sure that everything was lined up here. I think when I started off, I didn't have a probe selected, so I had everything offset by some small distance. Looks like we're good to go here. So let me get back into that dialog. And, again, simulate shows you a simulation. Verify, on the other hand, will move the machine and perform the measurement. And that updates the measurement result in this environment here, such that when we go to report that feature, results that are meaningful. So for instance, if I were to report that plane that I just measured, probably not so concerned about XYZ, but maybe just flatness of that plane. I get some actual result here that reflects the flatness of that plane we've just measured. So let's measure some other features, and we'll start to talk a bit more about this path planning that the software performs for you automatically. So first thing, noting the cone that we've created, this cone measurement. Notice in the graphics I've got an S and an E, so that signifies the start and the end of that measurement. So particularly noting the end point, this cone. Last measured feature in any given program will move the probe so that it clears the top of the part by some user configurable distance. However, if I add another measured feature to my program, so the circle, you notice there's that endpoint up high for the circle. We go and review the cone that we created previously. Endpoint, instead of being all the way up above the part, is here local to the cone. So as you're adding new measured features to your program, that start and end point, not only for the measured feature you're creating, but for adjacent features within the program will be updated automatically to create a more efficient and continuous, linked series of measured features that don't always simply go completely above the part, but will move in a more efficient manner from one feature to the other. So there's a couple things that kind of tie into that. If I just start to measure the series of features here, I'll push this thumbtack, meaning I'm repeating that operation over and over again. So it just allows me to quickly pick a series of 2D features, in this case circles, create those measurements. Now, if I were to either put my cursor somewhere different in my program, so here, circle 2, noting the path of circle 3, where it's linking directly from circle 2 to circle 3, by placing my cursor here and adding another measured feature, we end up with a link path now that connects that previously measured circle to the slot. And then if we click on measured circle 3, we see the start point for that circle automatically now is linked to that newly added slot feature we've just added to our program. So another case of that, let's take this cone that we had at the very beginning of our program. Let's just drag it to a new location within our program. I've dragged it all the way to the end of the program now. Now, if we look at each of these measured features in sequence, you can see all of those probe paths are updated just by virtue of adding features midstream in the program or even dragging the features within the program to a new location. So any type of add moves and tip angle changes and clearance moves that you may have done 20 years ago, that's no longer needed with this type of software because it takes care of the probe path operations for you automatically. Another example of that, let's use this CAD Teach 2D. We'll pick a circle, this time on the side of the workpiece. Now you can see the probe path that's created actually includes a tip angle change. Run that measurement here real quick. You see it indexes the probe laterally such that it can access that side of the part. So if we were to program maybe a couple features on that side of the part here, so immediately afterwards, maybe the slot feature. So you've got a link path now from that circle immediately to the slot, and then again back up to the safe ceiling height. So, Susan, the shapes of the parts that you might inspect, are they more or less geometric features? So as types of features that you've measured thus far?
We do prosthetics, so
okay.
Our parts are all different ways because we make ankles and feet and knees and elbows and that kind of stuff. So
right. So on those types of surfaces, you would probably expect to measure that surface and then output a profile evaluation of that surface. Is that a fair assumption?
Yes.
Okay, great. So let me measure. This time, you may have noticed when I clicked from the CAD Teach tools, I use this cloud. So a point cloud is going to be just a collection of points, typically on an irregular surface like you described. So here I've got a series of points. In this case, just for sake of time, I've got a single band of points. Yeah, you could have multiple rows and columns of points. But here, I'll measure 42 points along that irregular shaped edge. And we'll have an opportunity to look at the profile reporting and visual analysis that we can do on that type of surface. So already, because of a setting that I have turned on in the software, I'm immediately getting deviations on each of those points. So we'll talk a bit more about that once this measurement is complete. So the CMM that you've got, Susan, do you know the make or model of the CMM by any chance?
They told me it's a DCC that we run.
Uh,
Let me look.
Does it,
QX Soft is our program.
okay, so it's already running CMM Manager.
Yeah.
So the reason I asked is I was curious whether it was something that was compatible with our software, but being that it's already running, then clearly it must be.
Yeah.
So here we've got some analysis that happens immediately in the CAD view. And you can imagine if you've got more than the 40 or 50 points that I've measured, that could get a little busy. So what
Right.
you can do is from the CAD graphics, we can right click and we can take this live report that we see, save it automatically to our report document. So that clears up our main CAD view, but then you'll see if we go to the report document, automatically what we saw in the CAD view is converted into like a graphical snippet. Now, we could open up this graphical report and manipulate it and kind of tweak it to our liking. So in this case, the first thing I would probably do, all of these annotations, let's let's start by getting rid of all of them. And let's maybe manually annotate just the first and the last point. So now that manual annotation that I've created, if I double click on either of those, I can change it to what we call a sequence number. So I've got a P1 and a P42. So you remember I measured 42 points on that surface.
Right.
So this gives the viewer of this report document some sense of where the beginning and where the end of that series of measured points was. What that helps with is when somebody's looking at the text portion of that report output, you see you've got an overall profile that's mentioned here, but then you've got each individual point, P1 all the way down to P42 is got some dimensional information associated with it. So we can also clean up this reporting output. Let's turn off the X, Y, and Z. We'll leave just the 3D and the profile. Let's change our tolerance. Instead of plus or minus 2, let's try plus or minus 3. So we'll be using a bit more of the bandwidth here. Now you can see just from the text reporting, you've got a bunch of points that are trending towards the low side. And any of these that are with the red text, those are points that are actually out of that plus or minus 3 tolerance range. I also see a line that's highlighted in blue and a line that's highlighted in red. That indicates the high and the low point in that series of 42 points. And that's all kind of tethered together here. When we go back to our graphical report, we edit that graphical report, we can actually mark that min and max point so that, I don't remember the point numbers that we were just looking at. P9 and P26, that's those 2 points there in that series of points. So very quickly, just from the color of the little bar graph that you get here, or the heat map related to this bar graph, you can see all of those points are trending towards the low deviation. Or if we had points that were more green or turquoise or blue, they'd be closer to nominal or maybe on the upper side of the tolerance zone. Another way of looking at that same type of output, we could change our display mode. Instead of these colored discs that we see now, pretty typical scenario would be to use what we call spike deviation. So with the spike deviation, I'm going to look at this workpiece directly through the back edge. I'm going to magnify these spikes. So now the size and the direction of those spikes is a magnified kind of view of the actual deviation of that surface. So I can imagine, on your like prosthetic shapes, something like this would be useful. You could cover a surface in data points and then get a sense of where your high and low spots are and where the problem areas are and what you might need to do to address that becomes much more visually apparent.
Right.
So as far as measuring features, do you have questions? Does that all pretty much make sense?
That all makes sense.
Okay. So let's spend a little time. We looked at like the kind of graphical reporting and analysis of an irregular surface. Let's take a step back and we'll do some just basic reporting as well. Before doing that, we take a minute to verify, just so I've got actual measurement data for some of these measured features. So give me a second here just to measure a few of these features. Otherwise, when we report them, it will show zero deviation, and it's not nearly exciting to look at a report that has perfect part compared to something that has some real deviation. We'll measure one more circle here and then this cone, and that should be good enough to at least get started. All right, so maybe one more feature here I would like to measure. Let's measure this plane on the top edge, kind of angled plane that we've got here. And I had my cursor in the wrong spot when I added that, so let me just move that up one step in the program and run that measurement real quick too. So now we've got at least kind of a collection of features here that we can use for creating some reporting and constructions and so on. So even before we get to the reporting, let's real quick look at these constructions. There's a couple I'd like to do. So first off, we'll do a line construction. So a line at the intersection of two planes. So that plane that I just measured, and the intersection of that plane with the top surface of our part. So that gives us a line where those two planes intersect that you wouldn't be able to measure directly with the CMM, but by measuring those two adjacent surfaces, you can come up with that resultant line. Similar type scenario, we could intersect a circle, a cone. So the cone that we measured, and then again intersecting with the top plane. So that gives us a circle, very uppermost edge of that cone where it pierces the top surface of the part. And maybe one more construction. This time we'll do I'm aiming to do a circle construction, and you see here I can construct a circle through 3 points. In this case, I've got this bolt pattern where I've got 6 bolt holes. So this particular construction only allows 3 inputs. Anytime you've got that kind of over-constrained scenario, we can do instead a best fit construction, pick circle, and we can just start to pick from CAD here the features that we'd like to use to construct that bolt pattern circle. So now we've got a bolt pattern that's represented by those 6 previously measured circles. So now let's actually go to this reporting tab, and we'll first look at a couple of these features that we've just constructed. So maybe here a distance between. So let's look at a distance between that constructed line that we created and the line that we measured on the front edge of the part during our alignment. That can give us a 3D distance in between those two lines. So the other feature that we constructed, the circle here at the top of our cone. Let's pick on this very first button here, feature report. We'll pick on our cone. So here we can output like an X and Y coordinate and then an angle of that cone. You notice it doesn't give an option for any diameter. Hence the constructed circle that we created. So using that same button, this time we'll pick on the circle instead of the cone. So now we can output maybe just the diameter. That's giving us the diameter of that conical shape, again, at the very upmost surface where it, exits that top surface. So another construction that we might do, using that same button, what's the diameter of our bolt circle? So 1.625. See there's some small amount of deviation there. Maybe we also turn on circularity so we see the roundness or the run out of that bolt pattern. Another related reporting operation on that same circle, let's look at concentricity, constructed bolt circle in regards to the center large diameter bore. So for each of those report outputs we're creating, report output is added automatically to this report document. So the feature name or the label and the nominal actual deviation characteristics of each of those report outputs is added to this report document. So in terms of reporting, what would you say you would typically want to do in terms of report outputs? Is it a case where you're printing a paper report document for each workpiece, or are you planning to save it electronically? Or
what we do is we do save it electronically, but we also print it to give it to the CNC operator so he can see what's going on.
Okay. So with that said, something I might suggest, let's create what we call a graphical report. So it's the same type of graphical report we saw with that profile analysis. But what we'll do now is take some of these traditional report outputs that we've created and drag them into this report document. So what this is going to allow me to do is give your CNC operator, like you said, something that they can use to adjust the machine. But the benefit here is they can see immediately on this graphical report, which feature is which. The CAD coordinate system is displayed, so they know, if they've got to make an adjustment on one of these things. On the traditional report output that simply list coordinates, and in a case like this where maybe the X coordinate needs to be adjusted or the Y coordinate. Without that picture, there may immediately be a question of, okay, which way do I really need to move this if they don't have that frame of reference? Where having, a report document like this, the operator needs to make an adjustment one way or the other. It's immediately obvious, which way the axis system runs relative to the shape of the part. So what we see a lot of people do is they prepare a report like this that has all kinds of pictures that are used internally for evaluation or making adjustments. But then the actual printed report that gets kind of sent along with the part itself or filed electronically or whatever it may be is going to be the kind of simplified report document. And each of those reports you can set up so that they're printed or saved or whatever it is that you want to do with that report document. So independently, each report can be set up to be, like you said, printed or saved to different sources. So then you can give the appropriate report document to your operator, and then still file your complete report document electronically every time automatically.
Hello.
Susan, I still have you here by audio.
Okay, good. Kind of froze up for a minute.
Okay. So, any other questions with reporting? I'm just going to take these series of circles that we had and quickly create a report output for actually all 8 of these.
Okay.
I'm guessing your microphone or your webcam must be
Yeah.
going in and out of service there, but I've
Yeah.
still got you here.
We had an internet issue for a second,
Okay.
even though I'm hard drive connected.
All right. So at this point, maybe if you've got some questions for me, I can try to answer specific questions that you might have, whether it's reporting or measuring or otherwise.
I don't have any questions right now. What I've been learning is pretty much all of this. I'm going to take a class in November in Ohio.
Okay. Great. So you're coming to our facility then for training.
Yeah. Yes, I am.
Great. Okay. So you've probably been talking to Tom already then on the training front.
I haven't. My boss has.
Okay.
So that's all been done, and I'm already registered and everything. So.
Okay. Great. So I've got another participant in here, Susan, and I think they just spoke up. I'm sorry, I missed you joining.
Yeah, hi. My name is Andrea. I'm joining from Serbia.
Okay.
Sorry, I only logged in later on, so I didn't pick up your webinar in completeness, but still, it was very informative so far. But I have a couple of questions, if you don't mind.
Yeah. So before you have questions, I can just mention these webinars are recorded automatically. So once we're done with today's webinar, I'll save the recording and prepare a link, email it to you so that you can catch the first 15 or 20 minutes that you've missed.
That's great. That's very good.
Great.
So I have following questions. So you've been showing the version for computerized measuring machine, the equipment which is with motors, right? But there is also the version for measurement arms.
Correct. Yeah,
But
so the version. Go ahead.
I'm guessing there is not a big difference in way how you measure and create reports and everything.
That's right. Yeah, the high level functionality of the software is identical. So the biggest difference you would see on a portable arm, so let's say that you're measuring a plane using these CAD teach buttons. So on the motorized system, you see something like this, like you mentioned, that creates the measurement path automatically. So I can show you the interface for a manual system. I'll click on that same plane, and the dialogue is considerably simpler here. So it's asking me how many points should be measured. It gives me an opportunity to physically measure those points. Right. The one thing that's missing here, because this is configured as if it were a traditional CMM, not a portable arm. Also on a portable arm, you would have an option to do either discrete points. So for each point that you're collecting, you're pushing the trigger one time. Also, there's an option on a portable arm to do what we call scanning. So you would place the probe on the surface, push and hold the measurement button, and drag the probe across the surface. And then the software can be configured to just collect points in either a by time or by distance basis.
Really, there's this capability inside. It's quite surprising and in a positive way. I didn't know that's possible with the arm.
Yep. Yeah. So, with an arm, on a circle, for instance, you could simply drag the probe around the circumference of the circle, and instead of having 4 or 5 points, you could have, maybe 50 or 60 points immediately. So yeah, all of those settings would be available here in this dialog, for configuring that one mode versus another. But, otherwise, what you see here would be pretty similar. So when you click on verify, the software, instead of measuring automatically, now the software simply highlights the feature that you should be measuring and then tells you, how many points have been measured. Aside from that, yeah, everything would be, nearly the same in terms of alignment and reporting and so on.
Okay, okay. So I wanted to ask you also, do you think it would be possible to train ourselves to use this? Because we got an offer from your distributor and they're in a different country and they propose to come over here, which is bearing some cost for the fuel and
Yeah.
everything.
So the reseller, I assume, is in Poland?
No, I think for us it's a Croatian company through company called Texim. Do you know Texim?
Exit. Yes, we know them. Yeah, so what we could do, we have some training materials that are geared primarily towards a motorized CMM, but we could share our basic training materials with you. Again, from a high level perspective, that would be enough, at least where you can operate the software. There are some unique aspects of using a portable arm. I think that probably a web session with your local reseller, they can at least show you the basics for calibrating the probe and just doing the basic measurement tasks.
Right,
Yeah,
right.
generally speaking, I think if you had access to our training materials that we have available as a PowerPoint, you'd probably be able to learn the software on your own. In addition, there's several website resources. So we have some YouTube tutorials, and we have a support portal that has like some knowledge base articles that might be more geared towards portable arm use. So I can look and see what resources we have available, and certainly could share with you.
Excellent, excellent. And what I wanted to ask you also for the installation, how difficult would it be to install the Faro arm with this software? Would software be able to pick up the Faro arm from USB port, or is it more difficult than that?
Yeah, so you just need to have the Faro USB drivers installed, and then our software should work immediately. One thing I would caution, what Faro arm model is this? If it's a gauge arm, they can be problematic, but if it's anything else, it should be just plug and play.
We're planning to connect it to, we have two arms, but we're planning to connect it to Faro Platinum.
Okay, yeah, that's an easy one for sure. So the USB drivers that are already on your PC, our software will communicate directly to those, so you won't need to make any changes. It'll simply be installing our software, and it should just work immediately.
Do you have any version with limited functionality which would allow us just to check if we connect the arm, or is there
Yeah.
any?
So if you go to our website, I'll bring it here to this monitor. In the top navigation of our website, so the website is just qxcmm.com, which you know that you were here to register for today's demo. Here in the navigation, this free trial.
Free
You can
trial.
download the software and follow these instructions to generate a license key. And yeah, we'll even help you remotely to ensure that the software will connect and operate your arm.
Okay, okay.
It's a
Maybe we
30-day trial, so you'll have time to not only verify that it works, but also hands-on time with the software.
Okay, okay. Sounds good. Sounds good. We're probably going to try this. Okay, and last question is maybe not that related to actual software, but more to the practice of using it. So, because we're sort of like a job shop in which we every time we make unique new part every time, and sometimes we don't get even 3D models for this. So most of our measurements on computerized and portable CMM is we just measure points. We don't have 3D models to compare it against.
Sure.
But sometimes very rarely we do this. So it just, I mean, do you know, are people using this without 3D model functionality or not?
Yeah, I would say with portable arms, many people use CAD models because we see a lot of people with portable arms inspecting these irregular surfaces, as Susan mentioned. You know, she's got with the prosthetic type parts, a lot of like sheet metal applications. You're doing the same type of thing. But yeah, even if you don't have a 3D CAD model, this whole collection of the blue toolbar buttons will be giving you an option to just immediately take some measurement. So a cylinder, for instance. So again, here I'll have to move my machine around by joystick because it's a motorized system.
Right.
Functionality would be the same, on your portable arm. Basically follow the prompts from the software. I move from point to point here. Once I've collected a sufficient number of points,
and can this geometry be exported later in any CAD format?
Yeah. Well, not any CAD format, but yeah, if you come to this import-export tab, at the beginning of the demo today, I imported the CAD model that you see. But you also have an option here to export. So you can either export as raw data, which will create a text file with just raw XYZ data points.
Right,
You can also export features. All features can be exported in IGES EXF format. For a 3D part, probably IGES would be the format that you would use.
Right. IGES is good. IGES is good. IGES is good. Okay. Thanks. This would be all of my questions. Thanks.
Okay, great. Thanks for joining today. Sorry I missed that you jumped in here later. Once I get started with the demo, sometimes I miss when I've got additional participants jumping in.
No problem.
Okay, so Susan, I'll bring it back to you if you've got any questions.
Not at this time. Everything looks good.
Okay, great. So yeah, as I mentioned to Andrea, we've recorded today's demo. So if you'd like, I can send you a link for today's recording. You can review it at a later time, or if there was something that I went through quickly and you'd just like to see it again, that'll give you an opportunity to go back and what we talked about today.
Yeah, link would be good to watch whenever.
Yeah, great. Well, I'll do that. And Susan, we look forward to seeing you here in the coming months for training. And Andrea, I think you're in good hands with the guys at TechSimt. Presumably you're talking to Philip or Igor?
Yes, Igor, yes.
Okay, great. Well, yeah, so thanks for joining today. I know it's probably pretty late for you, so I'll follow up by email, and if you've got additional questions, feel free to reply back and comment with any further questions.
Thank you very much. This is great way to market the product. It's really useful. So I suggest you keep persisting in doing it. It's really valuable.
Yeah, we've done this for a long time. So yeah, thank you.
Thank you so much.
Yeah, thank you guys both for joining today. We appreciate it, and we'll be in touch.
All right.
Thanks. Bye.
Bye-bye.